All right, so these are going to be the first 5 questions for your first semester exam review. So these first several are about limits and continuity for the most part. So for the first one says, let f be the function defined above, and we have this piecewise function. Which of the following statements about f is true? And then if you look at all of your answers, they're all saying things about continuous and differentiable. So we got to figure out, is this function continuous and is this function differentiable? So continuous means that the limit as we approach our x value from both sides is equal to the value of the function. Easiest way to do that, though, is we just plug in this point right here, 5. We plug that in to both of our equations, and we see if they're equal to each other. So we have negative 5 squared plus 3, which would give us negative 25 plus 3, which is negative 22. And then if we plug in 5 into our second equation, we have negative 10 times 5 plus 28, which is negative 50 plus 28, which is negative 22. So that means the limit as we approach 5 from both sides is negative 22, which is also what we get if we just plug 5 in to the first equation, because that's where we're supposed to equal 5. So our limit is the same as our function, so yes, it is continuous. So we can get rid of any answers that say not continuous. So now we have to figure out if it is differentiable. So remember, differentiable has to be continuous for it to be differentiable. It can't have any sharp cusps or corners, and there can't be any vertical tangent lines. So when we have a piecewise function, if it's continuous, that part's good. But what we have to check is if there are sharp corners where the two different lines meet. Because a lot of times when you have a piecewise function, you have sharp corners where you separate the two pieces. So to figure out if it's differentiable, we have to figure out, is the derivative the same for both of those functions when we plug in 5. Essentially, we're going to take the limit of the derivative. So the derivative for our first one would be negative 2x plus 3. And then if we evaluate that when x is equal to 5, so we're taking the limit of that as x approaches 5, we would have negative 10 plus 3, which is negative 7. For our other equation, if we take the derivative of that, I took that derivative wrong. Oops. That derivative is not negative 2x plus 3. That derivative is just negative 2x. Evaluated at x equals 5 is negative 10. My bad. Derivative of the second one is negative 10. Evaluated at x equals 5 is still negative 10. So the derivatives are the same, so it is continuous and differentiable. All right, next one, we have a graph, and it asks, what is the limit as x approaches 1 of f of x? So we're going to come to x equals 1, and we're going to look at what is our graph approach. So on the left side, we're looking at this line, and we're approaching 3. So our limit as we approach 1 from the left would be 3. As we approach from the right side, we're looking at this line, and that's approaching 1. So the limit as x approaches 1 from the right is equal to 1. Because these limits are not equal to each other, that means the limit does not exist. The point that's down here does not matter when we're talking about the limit. The limit has nothing to do with the actual point. It's about what it approaches from both sides. Okay, next one. How many vertical asymptotes does the graph of f of x equals x minus 2 over x to the 4th minus 16? So vertical asymptotes are going to happen when your denominator is equal to 0. But first thing we do when we are asked about vertical asymptotes or points of discontinuity is we factor. So our numerator stays as x minus 2. In our denominator, x to the 4th minus 16 is difference of squares. If we square root both of those, we would get x squared minus 4, x squared plus 4. But then we could factor again because x squared minus 4 is also difference of squares. So we would have x minus 2x plus 2. X squared plus 4 does not factor because it's not difference of squares, it's adding. All right, well then the x minus 2's would cancel, so that's gone. So we're left with x plus 2 and x squared plus 4 for our denominator. This part that cancels is where we get what's called a point of discontinuity or a hole in our graph. To find our vertical asymptote, we set our denominator equal to 0. So we would get x plus 2 equals 0, which means x equals negative 2. If we set x squared plus 4 equals 0, we would end up with the square root of negative 4, which is an imaginary number. So this part does not give us a vertical asymptote. It's just x equals negative 2, which means there is one vertical asymptote. All right, number 4, we've got the limit as x approaches negative 3 of x squared minus 9 over x squared minus 2x minus 15. So when you're taking a limit, first thing you always try and do is just plug in your number. So we would do negative 3 squared minus 9, and then negative 3 squared minus 2 times negative 3 minus 15. Negative 3 squared would be 9, so 9 minus 9. Negative 3 squared is 9. Negative 2 times negative 3 is positive 6, minus 15. 9 minus 9 is 0. 9 plus 6 is 15. 15 minus 15 is 0. So we get 0 over 0, which is what we call indeterminate form. I don't think I spelled that right, but we're going with it. Okay, indeterminate form. Yeah, that's definitely not how you spell indeterminate. Whatever. So that's indeterminate form, which does not mean non-existent. It does not mean that the limit does not exist. It means that we have to do other math first. So we're going to come back over here to our original function. Now we're going to factor it, which, by the way, you could have just factored this from the beginning. It's typically going to be something that you need to factor. So numerator is difference of squares, so x minus 3x plus 3. Denominator is a quadratic, so what goes into negative 15 and adds up to be negative 2, so that would be x minus 5x plus 3. Then we can cancel x plus 3, so now when we take the limit as x approaches negative 3, we're just looking at x minus 3 over x minus 5. So negative 3 minus 3, negative 3 minus 5, that's negative 6 over negative 8, which simplifies down to 3/4. All right, and then last one for this video, f of x equals 2x squared plus 5 to the power of 7. We want to take our derivative, f prime of x. So notice we have an inside piece and an outside piece. This is going to be chain rule. So chain rule, derivative of the outside, so bring the 7 to the front, leave the inside the same, power drops down by 1. That's the derivative of the outside. Times, you got to remember to do the derivative of the inside, so the derivative of 2x squared plus 5 would be 4x. Then we can put the 7 and the 4x together because they're all being multiplied. And when it's multiplied, you can multiply anything in any order that you want to. So 7 times 4 is 28. Put the x in front. And then we've got the 2x squared plus 6, or sorry, 2x squared plus 5 to the power of 6 down at the end. And then this matches answer choice D. All right, so that's the first 5 questions. If you want to see the next 5, watch the next video. Ask questions if you need to.